Hello.
All right. Theoretical and experimental probability. Before you read anything, tell me what you think theoretical sounds like.
Theoretical.
Like a theory.
Theory.
What is a theory?
Something that
It's like what you think it's gonna be.
What you think it's going to do? Your theory, you have a theory that, I have a theory, that if you do your work, you'll make it great. It's probably a proven theory, but still. Yeah. Yeah, it's like a theory. And then what is an experiment?
A test.
A science.
Who said a science? It's a science. Yes, an experiment is a test. It's actually performing whatever you think is going to happen in theory, right?
Yes.
So that's the same with probability. I'm not going to read through all this right here. You can read it if you want. It's kind of confusing. I prefer to go down here, see right down here where it says theoretical probability. This is the easiest way. Theoretical probability is what's that word? Expect to happen. And experimental probability is what actually happens. So if I were to flip a coin 10 times, theoretically, I would land on heads 5 times, right?
Yes.
But if I went through and actually did it,
You might land on
I might not.
times.
Yeah, I might land on it 3, I might land on it all 10. You don't ever know. So that's what we're doing today. It goes a little bit deeper than that, but we'll get there momentarily. So look up here at the top. Amanda, whoever's humming, can you stop? Amanda used a standard deck of 52 cards and selected a card at random. She recorded the suit of the card she picked and then replaced the card. The results are in the table below. So if you look at number 1, it says, what is the theoretical probability of selecting a heart? I'm going to tell you the answer to that. And I'm going to see if you can figure it out. It's 1/4. If you don't know where I got it, that's fine. Give it a minute and look at it, and it might come to you. If it still doesn't after a second, then we'll talk about where I got it. But the theoretical probability of selecting a heart is 1/4. Who doesn't get it? Okay. So the theoretical side, because you're thinking all this over here has got to be what I should be looking at, right? But this is the theoretical side. How many suits are there? 4. And how many of them are hearts? 1.
Oh.
You see it now?
Yeah.
Okay, it's easy. It doesn't take long, I promise. And then, so if I do this side over here, this is the experiment. This is what actually happened. Okay, so let's look at number 2. Based on the results, what is the experimental probability of selecting a heart? How many cards did she draw?
30.
How'd you get that?
I added them all up.
Yeah, right here. 5, 10, 15, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So she drew 30 cards. And how many of them were hearts? 9?
Yes.
Good. Is that lowest form?
No.
What is?
Divided by
10 over 3.
3 over 10.
3
Oh, yeah,
10.
10 over 3.
And then if I said make that a percent, what would it be?
30%.
Good. Everybody with me? That's just me taking it a step further. Everybody good?
Yes.
All right, so what does number 3 say? What is the theoretical probability of what?
Selecting a diamond or a spade.
A diamond or a spade. I've got to keep my little chart up here so I can see it. Theoretical. How many suits are there?
4.
4. And how many are a diamond or a spade?
2.
2. Does that simplify?
Yeah.
To what?
1/2. Yeah.
Good. And so I can keep my chart up here. I want y'all to read number 4 to me. Ashley, will you read number 4?
Based on her results, what is the experimental probability of selecting a diamond or spade?
Good. How many cards did she select?
30.
How many were diamonds?
1. 5. 7.
7. And how many were spades?
11.
What's that together?
18. Yeah.
Is that lowest form?
No. I can never go.
What else can you divide by?
4.
What else?
6.
6. 18 divided by 6 is?
3.
3.
30 divided by 6 is?
5.
What is that as a percent?
75%?
Nope.
No. 60%.
60. Good. If you don't know, put it in the house. Decimal, 0. You with me?
Is it gonna ask us what the percent is?
No, but I will eventually. Turn the page to experiment 2. Dale conducted a survey of the students in his classes to observe the distribution of eye color. The table shows the results of his survey. So now, number 1, it says, what is the theoretical probability of choosing a child with green eyes? What is that?
1/4.
1/4. Everybody understand where 1/4 came from?
Yes.
And number 2 says, find the experimental probability of each eye color. So I know down at the bottom of your page it says like P, and then in parentheses it says blue. That means what's the probability of choosing blue?
Okay.
Okay? And then it says P, and then what, brown or something? And then P, and then green, all that. I can't show that on mine because I don't have enough room up here, so I'm going to do it. We'll work it up here, and then you can transfer it in there. Maybe. Hold on. All right. Let me get mine back up here. So how many, what'd you do, blue first?
Yes.
How many total people were there?
80.
80. How many had blue eyes?
12.
Is that lowest form?
No.
What is?
I don't know either.
Huh?
3 over 20.
3/20. What'd you divide by? Stop talking, boys. What'd you divide by?
4.
4. Good. And then we got brown, right? How many total people are in the class?
80.
80. And how many people have brown eyes?
58.
And is that lowest form?
No.
I know that because they're both even, right?
Yes.
I'll do the bottom.
I got some.
You got 48?
No, 29.
Oh. Did everybody else get 29?
Wait, yes. Wait.
And then we have what color? Green?
Yes.
How many total people were there?
80.
How many have green eyes?
2.
And that is 1/40.
140.
And the last one is what?
Hazel.
Hazel. And how many people were there?
80.
80. How many have hazel eyes?
8. That's 110.
Good. And you can put those in those little parts if you want to. It's up to you. Dylan, what are you talking about? And then number 3. What does number 3 say?
Oh.
Based on the survey, what is the experimental probability that a student in Dale's class has blue or green eyes? Experimental. How many total people were there?
80.
And how many have blue or green eyes? 14. Is that lowest form?
No.
What is? Are we good?
Yeah.
Got this part. We're going to move on. Go to number 5. And what did we get for brown? What was our probability of brown?
29.
29/40?
Yeah.
Look at number 5. This is kind of taking it a step further because this is where we're going. And you'll have IXLs like this week. If the distribution of eye color in Dale's grade is similar to the distribution in his classes, about how many of the 360 students in his grade would be expected to have brown eyes? What was the probability first of brown eyes? I want you to just watch. Okay? Because you're going to learn. This is not hard. And you already know how to do half of it. So this is what I'm saying. This is brown. This is total. If 29 out of 40, then how many out of 360? So we're familiar with this, right?
Yes.
We know how to solve a proportion, yes?
Yes.
So you can either cross multiply, that's fine, or can you cheat here?
Yes.
Times what?
Times 9.
Times 9. You do it downstairs,
You go upstairs.
and 29 times 9 is, I think it's
201.
261, I think. 261. So the answer to this question Do you see what the question is? What's it asking me? How many would be expected to have brown eyes in the whole grade? Good?
Yes.
Okay. We're going to skip experiment 3 on the next page and go right to the practice. I'm going to do a few of these and then I'll let you go and finish it on your own because that's your assignment. So if you look at number 1, if a car factory checks 360 cars and 8 of them have defects, how many will have defects out of 1,260? So our words are going to be defect over total, or cars. My suggestion is to go ahead and write the proportion lines once I've read it and know that's what I'm doing. How many have defects?
8.
8. If you're not writing, you're doing something wrong. 8 out of,
360.
360.
if 8 out of 360, what goes here?
1,000. Oh,
Yes.
Over.
1,360.
Good. Do you know how to solve that?
Yes.
Do it, please. All right. Oops. So you cross multiplied and got what? 360 equals like that.
Yes.
And when you divide it out, what'd you get for x?
I got 28.
Everybody get 28? Good. Look at number 2. If a car factory checks 320 cars and 12 of them have defects, how many of the 560 will not have defects? You see that?
Yeah.
How do you think you do that?
Subtraction.
Yeah, get the answer and subtract it.
Yeah, get the answer and then subtract it from what?
31.
From 560. So write a proportion. And we're going to have defects over total. And there were 12 out of how many?
360.
320. And it wants to know how many out of,
560.
but once you get x, that's not the answer, is it? No, you have to subtract it from what? 560. I'll let y'all do that one on your own. Let's look at number 3. Look at number 3. You plant 30 African violet seeds and 9 of them sprout. Use experimental probability to predict how many will sprout if you plant 20 seeds. So you have sprout over total. What do you think the proportion looks like?
9 over 30.
Not Jackson. 9 over equals. Good. Do you know how to solve that?
Yes.
Okay. So your assignment is the rest of these. I think there's like 13 of them. Not all of them are like this. Make sure you are reading, because a lot of them are like yesterday. Okay? Make sure you're reading. You're going to answer all of them. It'll be due tomorrow. But you have time right now, so let's get this party started.
This one again.